We're going to be looking at the one-way ANOVA test this evening. And first we want to define what a one-way ANOVA test is. This is also called the analysis of variance test. It does compare the mean of two or more independent groups in order to determine whether there is statistical evidence that the associated population means are significantly different. It is a parametric test. Now you might say, why do we not just use a t-test if we're comparing to the means of two groups? Well, when you're running, you want to compare multiple means. This is a much easier way to be able to compare the means so that you're not having to run t-test after t-test after t-test. The ANOVA is the way to go when you have more than two independent groups to test. There is a pre-test checklist with the ANOVA, just like there is with the t-test. Your N quota must be at least 30. There is a normalcy test to look at, so we'll be looking at the Shapiro-Wilks test, and also we're looking at histograms to determine if there's normalcy of the data, and there is homogeneity of variance. So if your data requirements aren't met with the one-way ANOVA, so just like I mentioned previously, you can run a non-parametric Kruskal-Wallis test. However, we won't be doing that tonight. We're going to make the assumption that our pre-test checklists are met with our data that we're looking at. So let's go over and look at the data real quickly. We're going to be looking at region versus enrollment, and we're going to compare the means of region 1, 2, and 5. So the first thing that we want to do is we want to go up to Analyze, and we want to click on Descriptive Statistics. After Descriptive Statistics, we'll click over on Explore, and then we're going to just run our checklist so that you can see how that we might do that. We'll clear this out so you can see how to pull this information over into Explore. So we want enrollment to be our dependent variable, and we're going to put region into our factor list. From there, we're going to go to Plots and click on, we don't want to look at a box plot. We want to look at a descriptive plot. We want to look at a histogram and not the stem and leaf. And we want normality plots with tests. So that way we can actually check two things here whenever we are looking at this information. We'll click that, and then we're going to click OK. And once we do that, our data information will pop up. So we can look at our N values for region 1, 2, and 5. Notice that region 1 is 72, region 2 is 66. So the N quota is met with those two regions, but with region 5, it's not met. However, for tonight's data, we're going to assume that that is actually met. Now let's look at the test of normality, and we're looking at the Shapiro-Wilks test. And for significance, we want this value to be greater than 0.05, and we actually see that it's 0.000. It's really not 0. There is a value that will be there. All you have to do is double click on it, and now that will show up whenever you kind of hover, and you can see that that is not 0. That was actually 2.37 times 10 to the negative 14th, which is a very, very, very small number. The same thing for region number 2. You can see that its value is again not 0. It's 5.67 times 10 to the negative 9. So both of those do not meet the normality test. The value should have been greater than 0.05. However, for region 5, it is greater than 0.05. So again, like I said, we're going to assume that all of our assumptions are met with this test, so you can see how to run the ANOVA on the data. Looking at the histogram for region 1, notice that you can see that it does not fit a normal curve very well. It is very, very skewed to the left. Also for region 2, it's skewed to the left and doesn't meet a normal, or doesn't fit into a normal curve very well. And then if we look at region 5, here's another way you can go down. You can just click it over here, and it should take you to region 5, but it didn't. So here's region 5, and it does fit a normal curve a little bit better, which it showed us that that was significant in this Shapiro-Wilks test. Now we're going to go to Analyze, and we are going to go to Compare Means. So click all the way down, and here you can see the one-way ANOVA. So we'll click on that, and I want to reset this. So we'll put enrollment into the dependent list, and we're going to put region into the factor list. At this point, we want to click on post hoc And here, since our n values were not equal, we're going to use the SIDAC test. If they were equal, we would use Tukey, but they're not. There was one that was 72, 66, and 23. And so since they're not equal, the n values are not equal, we'll use SIDAC. We'll click continue. And now the next thing that we're going to look at is we're going to go ahead and click on options. We'll click on homogeneity of variance because that is the other qualification that you would need to check if you're running this test to see if it's the best test for your data. And so we'll click here, continue, and then OK. Once we do that, looking at our homogeneity of variance, we're looking at based on mean, and we see that the significance is not greater than 0.05. So that particular qualification is not met. However, we're still going to use the one-way ANOVA. So looking at the significance between groups, we can see that there is some significance somewhere between actually the 5 groups. Notice that this value is 0.001, which is less than 0.005. That is what we're needing to look at to be able to reject the null hypothesis that there is no significant difference. But we're going to compare now the different regions. So we're comparing region 1 to region 2 and 5. So we'll look at region 1 versus region 2. Come over to the significance. Notice that the significance for region 1 versus region 2, I'm going to circle that real quickly, is not less than 0.05. It's actually greater than 0.05. So therefore, the two means between region 1 and region 2 are not significantly different. We can actually see the mean difference here is 933 between those. Now, looking at region 1 versus region 5, we see that the significance again is not less than 0.05. It's 0.411, and the mean difference here is 1,013 and 1,365. So again, we don't have significant difference between regions, the means of regions 1 and 2, or the means of regions 1 and 5. Now, looking at the means between region 2 and 5, so we'll just quickly compare that, and we see that that value again is not less than 0.05. So we don't have a significant difference between the means of regions 2 and 5, and you can see the difference in means is actually lower than the other two. It's 432. Now, if you want to go on down and actually compare those in another spot, you can see that the numbers are actually the same. Looking at region 5 versus 1, we see 0.411, which was the same as it was up here. Region 5 versus 2, we see that the value is 1.00, which is the same as here. And region 2 versus 1 right here is 0.470, which is the same as it is right here in whenever we have region 1 compared to 2. So the ANOVA test is a great way for you to be able to run multiple comparisons between many different groups without having to run test after test after test.